Hi guys, welcome to part 3. So as I said, I was at CPU voltage, so as you remember we set everything else for the time being, and we're going to start with manual. The reason we start on manual is because we are manually inserting the CPU voltage. Until you know you're 100% stable with your CPU overclock, then you'll go to offset, and I'll explain offset via showing you actually a guide that I actually wrote myself with the help of Swag, because it explains it pretty well and accurate. So we're going to leave it to manual and start at 1.25 volts. The reason we start at 1.25 because for a 4.5 gigahertz the average is about 1.25 volts. Now it could well be that you've got a really good chip and you could be at 1.1 volts, or it could be that you've got a really annoying chip and you're at 1.35 volts. You know, it depends. But just start at 1.25, and basically each time that you need to increase stability, you're going to actually just add to this. So you can see it went to 255. Let me just zoom in a little bit more so you guys can see this clearly. 255. If I go over, as you can see, keeps on going high. What you never want to exceed is 1.55 volts. Now it's not being tested in terms of reducing the lifespan of a CPU, but realistically do not ever go over 1.45 for your overclock. That's my personal take on overclocking CPU in terms of voltage. Realistically, I don't want to go over 1.45 for any overclock, but I am actually at 1.27 for my overclock, so I know this already. So I'm going to have it at 1.27 just to show you guys. But 1.25 is what you should start at. I had to go incrementally up, and then I finally found, hey, 1.27 is my desired voltage. So we're going to leave it there. PLL, you don't have to touch. The normal is 1.8, your standard. However, in my case, I had it 1.7. Don't touch it if you don't want to, or possibly if you can't. Some BIOSes I know don't allow you to do that, but basically it just, for me, it helped a little bit with stability. Now it depends from case to case basis. Some people have reported no differences. Some people reported lower stability. Just leave it at 1.8 to start with, and if you want you can tweak it later and do it like me, like 1.7. Spread spectrum, you want to disable it, and BCLK recovery, you want to disable it. So these ones you want to disable as well. So we have done pretty much everything in this AI tweaker page. Just to double check, it's always good to double check and look at what your things are. DRAM, yes, that's correct. CPU power, yes, that's correct. DGI plus, it looks okay. Manual mode, my voltage is 1.27, you should start at 1.25. My DRAM is 1.5, but I added a little bit to 1.55, that's my rated RAM. My PLL I set myself, CPU spectrum and BCLK recovery there. Now, we go to the advanced tab, as you can see there, and go into CPU configuration. With CPU configuration you can set several things. Now, in my case, I've got the i7-3770K, which means that I have hyperthreading. Now, hyperthreading doesn't come with the i5 processors, so you might not have this option, don't worry, but in my case, I have it enabled. Apart from that, everything else over here can pretty much be left alone, just because well, you don't need to touch it, and you don't need to change it. But as you can see, if you want to read those things which are there, which are written down there, so you guys can see, but yeah, you don't want to change anything there. Now, CPU ratio. If you remember, I had my CPU ratio at 45, which is 4.5 gigahertz. Well, there you go again. You've got 4.5 gigahertz, which is your 45 CPU ratio. Your Intel SpeedStep technology is what allows you to throttle up or throttle down your CPU. The reason you do this is well, simply because you want it to reduce. If you don't want your CPU frequency to reduce, well, you can disable that. But I suggest leaving it enabled, as I said, simply because it allows your CPU to save a bit of power. Now your C states, you've got C state 1, 3, 6, and package state support. Now what we're going to do is enable and disable some, and the reason we do that is simply because of the power saving. As I said before, the power saving is all about that, giving your processor some slack, let's put it that way. So we're going to enable C1 and disable the rest. So you have enabled C1, disabled C3, C6, and package state support. Some people say that some things should be enabled or disabled for certain testing, but in my respect, this is what I have. So that's CPU configuration done. PCH, high precision timer, is just something to do with reporting your CPU to certain programs. Intel Rapid Start I've got disabled. Intel Smart Connect, which I don't need, is when you can connect to your PC remotely, is disabled. SATA configurations, for example, what we're going to do is AHCI because I'm running on a SSD. Memory revamp, you're going to leave that enabled. Graphics, now if you have iGPU and you want iGPU, then you can have it enabled, but in my case I've got my GTX 660 Ti. I'm going to go to PCIe, which chooses the graphics card rather than the iGPU for my graphics, and we're going to leave the rest as it is. And then you can choose your link speed if you want, say Gen 3, which is times 16, or you just leave it on auto. USB configuration, leave it. And these are just little things. So for example, I never use the onboard audio because I've got a sound card, so I disable that. So this all depends on you, but the rest of them I would leave it on auto. As you can see, I'm just going through it so that you guys can see it. Now monitoring, as you can see, the monitoring of the speeds of the fans. Now you can set these to custom profiles and whatnot. You can say it to ramp up or give me a warning when it hits a certain RPM. You can also go for several different modes if you want. And in your boot section, for example, you can disable the full screen logo, and you can change how much time you have to enter the BIOS. So in my case, as I never want to enter the BIOS and advanced mode, if I never want to enter the BIOS, I put it as low as possible. I just give myself 1 second just in case. That's why I was spamming delete. But I've disabled my full screen logo because I don't want it or I don't need it. And I just changed over here the so that it boots in advanced mode rather than EZ mode. That's into the BIOS. It looks a bit different, which, I mean, boots like this rather than the other one where you have to press F7 and then enter this. And once you've done all of this and made sure everything is correct, then what you want to do is go to OC profile and save your profile to say number 1. So what I'm going to actually do is load my profile from number 1, and you'll be able to see that all my settings that I had, remember I was saying your monitoring of your temperatures, as you can see, these are my actual settings for my overclock. As you can see, all of them are set. Everything is already set over here. Just to show you guys, 4.5, as you can see, PCH, SATA. Just going quickly through this so you guys can see that this is my actual overclock for my system. My offset that I've got is 0.07 and the manual 1.27. So as you can see, what my overclock was disabled. Everything is as it was, as I showed you. Basically, it gives you a good idea of me being stable on my system, and this is my actual BIOS. So I'm gonna go to I'm gonna go to manual mode and 1.27 volts, just because I want to be on the same page with you guys so that you understand what I'm doing. So I'm on manual mode. I've got all my overclocking settings. Remember, this will be 1.25, but in my case I know I'm stable at 1.7. everything is set, you go to exit, save changes and reset, and press OK. And now we're going to boot back into Windows, and we're going to do some stress testing. And that's basically it. That's basically overclocking in a nutshell. That's all you have to do. The rest of it comes down to patience. It all comes down to you spending some time with the computer and, you know, letting it do its stress testing so that you know that you're fully stable. If you have no patience, then overclocking is not for you. It's simple as that, because you need to have patience to have a fully stable system. It's really simple, and I'm just trying to, you know, try and put it in layman terms for you, but that's basically it. You just always want to make sure that you're getting the right thing. So as you can see over here, I have got 4.5 gigahertz, and I think my power options are on high performance. Yes, they are. I'm going to change that to balanced, so it just drops down. But as you can see, my manual core voltage is inputted right there at 1.27. As you can see, it's just a bit above, but that's okay if it's just a bit above. But if it's too far above, that's when you should be worrying. So I'm at 1.27 as inputted on the BIOS for my core voltage, and you can see my core speed I try to attain is 4.5 gigahertz. Despite me hitting balanced, it does take a little time for it to kick in. It takes about 2 or 3 minutes sometimes for it to downclock its core speed. So we've got those open, which is great. And what we're going to do is open up Prime 95. There you go. As you see, I've just to prove to you guys, it's just downclocked itself right now to 1.6 gigahertz. Just showing you guys that it just takes some time sometimes to do that. So open up Prime 95. Remember what I said, custom and your memory in use, always check with Task Manager, even if you've done this a lot of times. So I'm going to go 6,000 just to be on the safe side, because I don't want to go 6,800. I'm going to hit OK. Watch the core temp. Watch the core speed and look at the core voltage. So you can see I'm a little overshooting with my voltage, and the reason why I'm a little overshooting is simply because of my settings are actually made for folding, which is a bit it's much more intensive than Prime 95. But that's something else. You just leave it ultra high and just monitor this. If it's too high, then drop LLC down to high, for example. And in fact, what I'm going to do is I'm going to show you that, just because I want you guys to understand what I'm trying to say. As you can see, Prime 95 is running, and as you can see, they're all running. Self-test, self-test, self-test. If this says stopped running, then that's when you should increase the vCore for your system. So as you can see, the temperatures are okay. They're 50 Celsius. As remember, I was delidded 55 Celsius. These go up after, say, about 3 hours of Prime. Your temperatures will go higher because there's more intensive applications that it's going to do, and everything is there. So what I'm going to do now is close Prime 95. What you do is, the best way to close it, by the way, is go on your taskbar, right click and press stop. And this stops everything. As you can see, it says not running. That's what you don't want to see, but obviously I stopped it there for a reason, and it stopped itself. So as you can see now, look at the voltage, 1.27 on idle, and 1600. So now I'm going to restart, and I'm going to reduce LLC. Now, I really want to show you this because people often say, hey, my voltage is not quite the same on my CPU Z than what I've got there. Normally it's because you haven't got enough LLC, but sometimes, and quite rarely, you can have too much LLC and therefore it's overshooting. So LLC is in here, and let's change that to high. So I've only changed that one down, as you can see, to high, and I'm going to boot. Save, change, reset, yes. So I'm going to do the same thing that I just did, but this time we should hopefully see that the voltage on my CPU is actually lower. As in, it's not going to be 1.8 or 1.82, it's probably going to be 1.7 or 1.65. Who knows? We'll see. We'll see what my chip does, so that you guys can understand it. So core temp, CPU Z, Prime 95. As you can see, I've gotten quite used to this. So as you can see now, remember before I was at 1.72? Well, now on idle, I'm on 1.64 and 1.72. It's varying. Now, I'm going to go to custom blend, again, 6000, just to double check with Task Manager. Yes, that's correct. Hit OK. Now, look at this. Look at that. Can you see? I'm at 1.25 volts now. Now, remember, in my BIOS I was at 1.27. I need 1.27 to be stable. Without LLC at ultra high, but at high it's at 1.25. But at LLC at high it's at 1.25. 1.25. So let me just write this down so that you guys can understand what I'm trying to say. Let's go for 72. At ultra high, which is 75% LLC, let's go maybe one font down to 48. CPU on load equals 1.282 V. That's what it was on before. At high LLC, which is 50% LLC, CPU on load equals 1.256. 1.256 V. CPU in BIOS equals 1.27 V on manual. So, it's pretty clear cut, as you guys can see. I'm just trying to put this into perspective for you guys so that you guys can maybe understand this a little bit better. The camera. Right, so as you can see, ultra high I get this on load, on high I get this on load, and in CPU BIOS I've got this. So it really depends what I want over here and what I'm trying to achieve, you know, what I want to get. Because I know that I've tested it on ultra high, I know this is the figure I want, and therefore I need ultra high LLC. It's good that I was able to show you this, and it's good that Windows was able to represent it. As you can see, there's usually two factors of a core voltage. You get two fluctuating things, but the most occurrent one is 1.256, which I've got over here. So as you can see, guys, you want to make sure that your LLC is correct and that your LLC is the one that you need. Again, I said that if this was, imagine this was 1.3 volts on ultra high, that's way too much. And actually high would have been my better one because it's closer to 1.27. Hopefully that makes sense. Closer to 1.27 for me, in my respect, is my aim. So on here, if I'm getting 1.3, or let's say 1.35 V, but on high I'm getting 1.256, then it's the high that I have to go for because ultra high is overshooting too much my voltage. Hopefully you guys understand that where I'm coming from. So now, imagine you've been running Prime 95 for 24 hours. You're fully stable. Woohoo! Good job. That's it's always a great achievement. So now we want to go to offset. Now, why do you want to go to offset? Well, offset is simple. It saves you power. It's usually, the temperatures are usually, I say usually because it occurred for me, but maybe not for everyone, that the temperatures are lower. And I've got an explanation over here, which basically explains it. I've got it on my phone, and I should pretty much read it out to you. So, for offset, it's very simple. First of all, you should know your manual V core. In my case, it was 1.27 V. Remember what I was saying? 1.27 V for my manual V core. So, I know my manual V core now is 1.27 V. Then you take your VID. Your VID can be found via your core temp. Now we've got core temp open, how appropriate. We've got VID. Now, you can see this VID is 1.0 2260, let's say, and basically this VID is what you're going to use to calculate your offset. You have to make sure that you are on 100% load, i.e. Prime 95 is running, so that you can calculate your offset. So first you want to make sure you're fully stable. Once you're fully stable and you know your core voltage, which in your BIOS, not in your Windows, so you take your BIOS voltage, 1.27 V in my case, and you take your VID in Windows, which in my case, which seems to be 1.3 or 1.26, and you calculate it. So I'll say it as I'd written down. Now your VID, like your voltage, which is over here, fluctuates with load. So that what you want to do is hit up Prime 95 and put it under the same load you used for stability on your manual settings. Leave Prime 95 running for about 5 to 10 minutes. Then look at your VID. Your VID will fluctuate, even on load. But take both notes, take notes and write down your VIDs. So you might have two. So in my case, 1.31 right here, and it goes to 1.2260, if I'm not mistaken. So then you do a simple maths. You take the most frequent VID, and you take your voltage in your what's it called? Your BIOS. And the example I've got here, I'll just use this. So for me is, well, I had 1.265 V previously, minus, this is my voltage in my BIOS, I minus it by my VID, which was 1.2209 at the time, which gives me a sum of 0.0441. If I round that, that's 0.045, and that's a positive offset. The offset can be negative. So let's say if this was 1.20, your offset will be minus, because it's taking a small number, minusing it by a bigger number, and it'll give you a minus offset. It'll be minus 0.0. So in this case, minus 0.2, yeah, 0.02. So this was a minus, but in my case it's a positive offset, so it all depends. So what we're going to do now that we know our VID, we know that we're fully stable on Prime, and that we know our core voltage, we're going to go into the BIOS and input our offset. And once we do that, we have fully overclocked our system. So as I said, I know my offset is plus 0.07, and as I said, if you're going to be folding, I suggest you fold and you find out your VID. No, I didn't go into, let's just hit reset, forgot to go into BIOS. Yeah, so my offset whilst folding was plus 0.07, whereas when I was Prime 95ing, my offset was plus 0.04. Plus 0.045, sorry. So there's a huge difference there in voltage. So we're going to hit that offset plus, as you can see, remember I was saying plus or minus, you can see here. So we're plus, and 0.07 is my offset. So there we go, guys. I know it's been a very long 3 parts, 25 minutes each, but I thought to make it a long video because you guys understand everything, and I can explain everything as thoroughly as possible. I hope this guide has helped you. If it has, please do like, leave a comment, subscribe, and check out the guide that Swag has done on overclockers.net, which I will link down, and I'll link down several other things that I've got in the description, simply because I find it could be useful for certain people. So there you go, guys. Hope this has helped you. Again, this is for an Asus, usually an Asus motherboard, although it can apply to other motherboards with Ivy bridge. So there you go. There we go, guys. Totally dubbed out. Bye bye.